Okay, hi guys. So let's solve this problem. Lead code 646 maximum length of pair chain. Now, this is actually the same kind of problem that we have solved earlier. So I would strongly recommend all of you to watch this first. That is greedy algorithms interval pattern. I've started a playlist. So uh, here we have it's actually the exact same problem. This was non-overlapping intervals, lead code 435. And if you've understood the concept of the envelope that I explained in that problem, this is exactly the same problem. Okay, so do watch this and then try to solve this on your own. You'll be able to do it in like 2 minutes. Don't worry about it. So, but let's understand this question. Just for the sake of completion, I'll add it to the playlist. So, see, maximum length of pair chain. Quickly, we'll understand the problem. Here I have given a set of intervals. So let me, for the sake of comparison, in that problem I had this pair was called an interval, a time interval. I would also consider this pair to be a time interval. So let's say 1, 2 is an interval, 2, 3 is an interval, 3, 4 is another interval, and I need to have an array of arrays in which I need to have maximum number of intervals such that the first interval, the ending time of the first interval should be strictly more than the ending time of the second interval, than the starting time of the second interval. Okay, so let's see 1, 2, 2, 3. Can these two be a part of my answer simultaneously? It can't. Why? Because the ending time 2 is equal to the starting time of the next one. I can't have that. The ending time has to be greater than. So I will not take 2, 3. See, I also had an opportunity of not taking 1, 2. I could have proceeded with 2, 3. So let's look at both the options. So 1, 2 and 2, 3 both can't be together. So I have neglected 2, 3. So I have considered 3, 4 after that. So 1, 2 and 3, 4 are the final answer. So I have two elements and that is the longest chain. But what if I had not considered 1, 2? So then I would have 2, 3 in my final answer. Okay, but then 3, 4 couldn't have been included in the final answer because 2, 3, this 3 is equal to start time of the next. This can't happen. The start time has to be more than this 3, right? So in that case, I would have only 2, 3 in my final answer, and that would lead to my chain length of 1. That can't be possible. So now here I will also, so my previous choice was correct. So now, of course, there'll be a number of choices, and one of the choices would be optimal. We do think about DP and recursion, but mostly in problems of intervals, greedy is like a set pattern. Like it will work, I think, in most of the problems. So do think about greedy first before we jump into recursion because it'll save a lot of time, I would say. Uh, so see, what we can do is firstly we have to if I'll just like straight away follow the pattern that I had followed previously because all the constraints match. In the non-overlapping intervals, what was our constraint? Our constraint was I need to remove minimum number of intervals. That means I need to include maximum number of intervals, right? And here this is the same constraint. I need to include maximum number of intervals so that the length is maximized. The overall length is maximized. So the main idea in that problem that I'd explained was that we need to actually get rid of these envelope kind of intervals. Why? Because this envelope kind of intervals take up maximum space and they reduce the number of intervals that I can see. In the place of 1, 2, and 3, 4, I could have considered this one large interval of 1, 4, right? See, all three can't come together. So either I have to consider 1, 2, 3, 4, or I have to consider this large interval 1, 4. So of course it's more like 1, 2, and 3, 4 would considering them together would lead to a longer array, right? Longer chain. So I would always try to get rid of these envelope kind of intervals. That is the main idea. So to understand the envelope, my pattern that I would follow is if there are any children, they should be like they should be placed before the envelope kind of interval. Okay, how will I do that? I will sort the entire vector of vectors or the array of arrays into according to the ending time. So you see 2, 4, 4, 5, 6. All of them are sorted according to their ending times. So 1, 2, 2 is the shortest ending time that I see. So 1, 2 is coming first. Then 3, 4. This now see 3, 4 and 1, 4. They both have the same ending time. In the process that they have the same ending times, my idea is that the envelope should come later than the child. So they have the same interval, but this 3 4 should come before 1 4. 1 4 is the envelope, it should come later. So for that, what I have taken is, if the ending time are same, the one with the like lesser start time should go after the one with the more start time. So that would ensure that 3 4 or the child gets in before the parent does. How will that help me? We'll see how will that help us in a while. Just consider this. That's what we'll do. Next we have 1 5. Okay, 1 5. Okay, 1 5, and then we have 5 6. Okay, now when I go about constructing the answer, how will I construct the answer? I would first go to 1 2, and this I would by default consider to be a part of my answer. So 1 2 is a part of my answer. Okay, then I would go to 3 4, and I would check, is the 3 more than the 2? Yes, so 3 4 is also a part of the answer. Then I will have to consider this 4. Is this 4 more than 1? No, it's not, right? That means I have encountered an envelope. So I will not consider this as a part of my answer. So next I would go to this interval 1 5. And I'm still here at 4, right? At this ending time, because this 1 4 was not considered as a part of my answer. So my ending time is still this 4 of this interval. Now, is the 4 more than 1 5? Right? Okay, I just messed up. I'm so sorry, guys. I'll just this part. Let me just start over. 1 2 I've considered. Yes, 1 2 I've considered. Great. Next, I would see that is 3. Is this 4? Is this lesser than? Is this lesser than the start time? Is this lesser than the start time? No. 4 is more than the start time. That means I have considered, like I have encountered an envelope. So I would just place 3 4 over here. Cool. Okay, next, so this 1 4 was not a part of the answer. So my ending time is still standing at this 4. I'm still standing at this 4. My next interval is 1 5. I've skipped 1 4, 1 5. So is the start time, that is 1, more than 4? No, it's not. So I will also skip this 1 5. That means 1 5 is another envelope I have encountered. Don't consider this. Next I'll come to 5 6. Is this 5? I'm still standing at the same 4, right? Because this was the last element that was considered in the answer. So is this 5 more than the whatever the last ending time of the last considered answer was? Yes, this 5 is more. So I would consider this 5 6. So my answer, final answer would be length 3. That is going to be my final answer. That's exactly what we have considered here. I have first sorted the array, right? Here is the code. So I have first sorted the array. So if the ending times coincide, then always place the like if the ending times coincide here, as I said, is the ending times are coinciding, both are ending at 4, always place the one with the more start time first. So 3 is a more start time, like greater start time, so it's placed before the envelope. That's how I've sorted the array. Next, by default I've considered the first element to be a part of the answer. Yes, and the ending time of the first interval is going to be what? It is going to be the, and always understand also this, guys, like the start of the answer. I'm always considering the first element to be a start of the answer. The first element can never be an envelope. The first element can never be an envelope, because to be an envelope you need to have the largest end time. You need to have the largest end time, right? So that can't happen. Okay, so great. We have the first, so that is why I've always considered the first array to be first element to be a part of the final answer always. Then what do? I go on and compare that. Okay, the next element is the start time of the next element more than my like my last added final answer was this. The ending time of my last added final answer is denoted by the variable time. So is my current start more than my last added elements ending time? If it is, then I would increase the count, and this newly added element, this newly added final element would, the ending time of the newly added element would become my time. So that's what. So please don't update this variable if we have not added a newly added element in the array. So we are updating the ending time only if the current current element is getting in the final answer, right? So when I'm trying to skip, like when I'm skipping these envelopes, I don't increment the ending time, right? That is the reason why. Be careful here. So only if my start time is more than the last added answer, only if my start time is more, like 5 6, only if the start time is more than my last added answers ending time, only then I'll get inside the array. Okay, so I hope that is clear. Yeah, it's exactly similar to what we have done previously. So do watch that video, both, and you'll be able to solve this on your own. So yeah.